In 1783, the English clergyman and natural philosopher John Michell wrote a letter to the Royal Society of London in which he described an idea so strange that it would take nearly 2 centuries for physics to catch up with it. Michell imagined a star so massive, so dense, that the gravitational pull at its surface would be strong enough to prevent even light from escaping. A dark star. He called it a body that would be completely invisible, detectable only by its gravitational influence on the objects around it. Light would fall back onto its surface the way a ball thrown upward falls back to Earth. The star would be there, but no one would ever see it. It would be, in the most literal sense, a hole in the visible universe. Michell's idea was ignored for over a century. Then, in 1915, Albert Einstein published his general theory of relativity, which redefined gravity not as a force, but as the curvature of space-time itself. Mass tells space-time how to curve. Curved space-time tells mass how to move. And within months of Einstein's publication, the German physicist Karl Schwarzschild, serving on the Russian front in World War I, found an exact solution to Einstein's field equations that described something extraordinary. A region of space-time curved so severely that nothing, no particle, no signal, no light could escape from within it. Schwarzschild had rediscovered Michell's dark star, but in a far more radical form. This was not merely a star that trapped light. This was a region of space-time itself that was cut off from the rest of the universe, a one-way door through which things could enter, but from which nothing could return. Einstein himself was disturbed by Schwarzschild's solution. He did not believe that nature would permit such an object to exist. For decades, he argued that some unknown physical process would prevent the complete gravitational collapse that Schwarzschild's mathematics described. He was wrong. In 1939, J. Robert Oppenheimer and Hartland Snyder published a paper showing that a sufficiently massive star, having exhausted its nuclear fuel, would collapse under its own gravity with nothing to stop it. The collapse would not halt at any intermediate stage. It would continue, relentlessly, until all of the star's mass was compressed into a point of infinite density, a singularity surrounded by a boundary from which no escape was possible. That boundary is the event horizon, and the object it defines is what John Archibald Wheeler, in 1967, named a black hole. The story of how physics came to accept what Einstein could not is itself a tale of intellectual courage. In the 1960s, Roger Penrose proved mathematically that gravitational collapse to a singularity is not a special case, but a general feature of general relativity, that any sufficiently concentrated mass will inevitably form a singularity, regardless of its shape, composition, or internal structure. His singularity theorems earned him the Nobel Prize in Physics in 2020 and established, beyond mathematical doubt, that black holes are not exotic anomalies. They are inevitable consequences of the laws of gravity. The universe does not merely permit them, it requires them. Stephen Hawking extended Penrose's work in the opposite temporal direction, showing that if gravitational collapse inevitably produces a singularity in the future, then the Big Bang itself was a singularity in the past. The beginning of the universe and the center of a black hole are, in a precise mathematical sense, the same kind of object points at which the curvature of space-time becomes infinite and the known laws of physics break down. The birth of the cosmos and the death of a star share the same mathematical DNA. This connection between cosmological origins and black hole interiors will become central to our investigation. The name is perfect, and it is misleading in equal measure. A black hole is not a hole in the ordinary sense. It is not an absence. It is a presence, the most extreme concentration of mass and energy that the laws of physics permit. A stellar mass black hole, formed from the death of a massive star, packs several times the mass of our Sun into a region smaller than a city. A supermassive black hole lurking at the center of a galaxy contains millions or billions of solar masses within a region smaller than our solar system. And the gravitational effects of these objects are not subtle. They warp space-time so severely that they distort the images of stars behind them, bending light around themselves in halos and arcs that were predicted by Einstein's equations and photographed for the first time in 2019 by the Event Horizon Telescope. That photograph, the first direct image of a black hole, deserves a moment of attention because it is one of the most extraordinary achievements in the history of science. The Event Horizon Telescope is not a single instrument. It is a planet-sized array of radio telescopes distributed across the Earth from Hawaii to Spain, from the South Pole to the mountains of Mexico, all synchronized to observe the same object at the same time. The target was M87, the supermassive black hole at the center of the galaxy Messier 87, located 55 million light-years from Earth. The black hole contains 6.5 billion times the mass of our Sun, and the image that the EHT produced, a glowing ring of superheated gas surrounding a dark central shadow, confirmed, with visual immediacy, what Einstein's equations had predicted a century earlier. The event horizon is real. The boundary beyond which nothing returns is not a mathematical abstraction. It is a physical reality, and we have seen its shadow. In 2022, the EHT released a second image, Sagittarius A, the supermassive black hole at the center of our own Milky Way galaxy, located just 26,000 light-years away. 4 million solar masses compressed into a region smaller than Mercury's orbit. Every star in our galaxy, including our Sun, orbits this object. Every atom in your body is gravitationally bound to it. The black hole at the center of our galaxy is not a distant curiosity. It is the anchor around which your entire existence revolves. Black holes are not rare. They are everywhere. Astronomers have identified thousands of stellar mass black holes in our galaxy alone, and they estimate that the Milky Way contains roughly 100 million of them. Every large galaxy in the observable universe harbors a supermassive black hole at its center. And in 2023, astronomers using the James Webb Space Telescope discovered supermassive black holes existing when the universe was less than 1 billion years old. Objects so massive and so ancient that their existence challenges current models of how black holes form and grow. They were already enormous when the universe was still young, as if they were woven into the fabric of cosmic structure from the very beginning. The formation of a stellar mass black hole is one of the most violent events in the universe. When a star more than roughly 25 times the mass of our Sun exhausts its nuclear fuel, the outward pressure that sustained it against gravity ceases. The core collapses in milliseconds. The outer layers, falling inward at a significant fraction of the speed of light, bounce off the ultra-dense core and are blown outward in a supernova explosion, an event so luminous that it can briefly outshine an entire galaxy. What remains is the core, compressed beyond the point of any known physical resistance, collapsing inexorably into a singularity surrounded by an event horizon. A star dies, and a black hole is born. The supermassive black holes at the centers of galaxies are more mysterious. No single star is massive enough to produce them. They may have formed from the merger of many smaller black holes over billions of years. They may have formed from the direct collapse of enormous gas clouds in the early universe. Or they may have formed through processes that we do not yet understand, processes that operated in the first moments after the Big Bang, seeding the universe with gravitational anchors around which the galaxies would later coalesce. The origin of supermassive black holes remains one of the great unsolved problems in astrophysics. But whatever their origin, their role in the universe is increasingly clear. Black holes are not destroyers. They are organizers. The The supermassive black hole at the center of a galaxy regulates star formation, drives galactic winds, shapes the distribution of matter across millions of light years, and determines the ultimate fate of the galaxy itself. Without the black hole, the galaxy would not hold its shape. Without the gravitational anchor at the center, the stars would drift apart, the structure would dissolve, and the organized complexity that makes planets, chemistry, and life possible would never emerge. The most destructive object in the universe is also, paradoxically, one of the most creative. It destroys everything that crosses its boundary, and in doing so, it creates the conditions for everything else to exist. But the event horizon is where the real mystery begins. And to understand why, you need to understand what the event horizon actually is, not just as a boundary in space, but as a boundary in the nature of reality itself. The event horizon is defined by a simple criterion. It is the surface at which the escape velocity equals the speed of light. Inside the event horizon, you would need to travel faster than light to escape. Since nothing can travel faster than light, nothing escapes. This sounds straightforward. It is not, because the event horizon is not a physical barrier. There is no wall, no membrane, no surface that you would hit if you crossed it. If you were falling into a sufficiently large black hole, you would cross the event horizon without noticing anything unusual. The space around you would look normal. The physics would proceed as expected. You would feel no jolt, no impact, no boundary. The event horizon is invisible from the inside. And yet, from the outside, the event horizon is the most dramatic boundary in all of physics. For an observer watching you fall in, something extraordinary happens as you approach the horizon. Your time slows down, not metaphorically, not subjectively. Your actual physical time, as measured by the outside observer, decelerates as you approach the event horizon. The closer you get, the slower your time runs, relative to the observer watching from a safe distance. At the event horizon itself, your time stops completely. The outside observer sees you freeze at the boundary, your image growing dimmer and redder as the light you emit is stretched to ever longer wavelengths by the extreme curvature of space-time. You never cross the horizon. From the outside observer's perspective, you hang there, frozen, for all eternity. This is not a thought experiment. The time dilation near a black hole is a measurable physical effect governed by the same equations that describe the time dilation measured by atomic clocks on GPS satellites. The difference is one of degree, not of kind. Near Earth's surface, time runs slightly slower than in orbit by billionths of a second per day. Near a black hole's event horizon, the effect is not slight, it is total. Time does not merely slow down, it approaches a complete stop, asymptotically, as the observer approaches the horizon. If you could hover just above the event horizon of a black hole and then fly back to Earth, you would find that millions or billions of years had passed in the outside universe, while only hours had passed for you. The event horizon is not just a boundary in space, it is a boundary in time, a place where the river of time itself comes to a standstill. This temporal asymmetry between the inside and outside of the event horizon is one of the most profound features of black hole physics. It means that the event horizon is not merely a spatial boundary separating two regions. It is a temporal boundary separating two fundamentally different experiences of time. The outside observer lives in a universe where time flows normally. The falling observer crosses into a region where, from the outside perspective, time has stopped. Two conscious beings, looking at the same event, disagree not just about what happened, but about when it happened and whether it happened at all. But from your own perspective, you cross the horizon in finite time. You fall through without stopping, without pausing, without any indication that you have passed the point of no return. Your watch keeps ticking. Your heart keeps beating. The boundary that, from the outside, appears to be an absolute barrier that freezes you in time is, from the inside, completely transparent. Two observers, two completely different descriptions of the same event. One says you never crossed the horizon, the other says you sailed right through. Both descriptions are physically valid. Both are consistent with general relativity, and both cannot be simultaneously true in the classical sense because they describe contradictory physical realities. There is a further asymmetry that deepens the mystery. From the falling observer's perspective, the journey does not end at the event horizon. It continues inward, toward the singularity at the center. And as the observer approaches the singularity, the tidal forces the difference in gravitational pull between the nearest and farthest parts of the observer's body increase without limit. For a stellar mass black hole, these tidal forces are extreme even at the event horizon, stretching the falling object into a thin thread of matter in a process colorfully named spaghettification. For a supermassive black hole, the tidal forces at the event horizon are gentle enough that a human could survive the crossing. But regardless of the size of the black hole, the destination is the same. The singularity, the point at which the curvature of space-time becomes infinite, the density becomes infinite, and the laws of physics as we know them cease to function. The singularity is the point where general relativity breaks down. Einstein's equations, which describe every other gravitational phenomenon in the universe with extraordinary precision, produce infinite answers at the singularity, and in physics, infinity is not an answer. It is a signal that the theory is incomplete, that it has been pushed beyond its domain of validity, that a deeper theory is needed. That deeper theory, which would unify general relativity with quantum mechanics, does not yet exist. It is the most sought-after prize in theoretical physics. A quantum theory of gravity, and the singularity at the heart of a black hole is the place where the need for that theory is most acute, because it is the place where the known laws of physics literally fail. What is at the center of a black hole? No one knows. General relativity says a singularity, a point of infinite density. But most physicists believe that the singularity is not real. It is an artifact of an incomplete theory, like the infinite self-energy of an electron in classical electrodynamics, which was resolved by quantum electrodynamics. The real answer, whatever it is, will require a theory that does not yet exist. And the nature of that answer, whether the singularity is replaced by a quantum bounce, a new universe, a region of exotic space-time, or something that our current mathematics cannot describe, is one of the deepest open questions in physics. This is not a paradox that general relativity can resolve on its own. It requires quantum mechanics. And when quantum mechanics meets the event horizon, the result is one of the deepest and most productive crises in the history of theoretical physics. But before we enter that crisis, let us pause and notice something about the event horizon that most physics discussions overlook. The event horizon is a boundary between two realities that depend entirely on the observer's position. What you see depends on where you are looking from. The same event, a person falling into a black hole, has two completely different descriptions, and the choice between them is determined not by the event itself, but by the observer. The event horizon is not just a boundary in space, it is a boundary in observation. It is the point at which the relationship between the observer and the observed becomes the defining feature of physical reality. This should sound familiar. It is the measurement problem of quantum mechanics applied to the most extreme gravitational environment in the universe. In quantum mechanics, the state of a system depends on the measurement on the observer's interaction with the system. In black hole physics, the state of a falling object depends on the observer's position relative to the event horizon. Both domains tell us the same thing. Reality is not observer independent. What exists depends on who is looking, from where, and how. The contemplative traditions recognized this structure long before physics formalized it, and they recognized it not in the context of black holes, which they had no knowledge of, but in the context of the deepest questions about the nature of reality and the self. In Islam, the concept of hijab, veil or barrier is not limited to its popular association with clothing. In Sufi metaphysics, hijab refers to the veils that separate human consciousness from direct perception of the divine reality. Ibn Arabi identified 70,000 veils of light and darkness between the human soul and God, veils that do not conceal a distant deity, but that constitute the very structure of created reality. The physical world, in this framework, is not separate from God. It is a system of veils through which God's infinite light is filtered into the finite forms of material existence. Each veil reduces the intensity of the light, making it bearable for finite consciousness. And the spiritual path is the progressive removal of these veils, a journey inward through the layers of reality toward the unconditioned light at the center. The structural parallel to the event horizon is striking. The event horizon is a veil in space-time, a boundary that separates two domains of reality. From outside, you see one thing. From inside, you see another. The veil is not a physical wall. It is a property of the geometry of space-time, a consequence of the way the curvature of reality affects the observer's access to information. In Sufi metaphysics, the veils between the soul and God are not physical barriers either. They are properties of the geometry of consciousness, consequences of the way the structure of awareness limits the soul's access to the infinite light. In Christianity, the Apostle Paul wrote to the Corinthians, "For now we see through a glass, darkly, but then face to face. Now I know in part, but then shall I know even as also I am known." The glass, the mirror, is the veil between partial knowledge and complete knowledge, between the limited perception of embodied existence and the direct, unmediated perception of divine reality. Paul's glass, darkly, is, structurally, an event horizon of consciousness, a boundary that defines what the observer can and cannot see, not because of the object being observed, but because of the observer's position relative to the boundary. In Hinduism, the concept of Maya, which we have encountered in previous investigations, describes the entire phenomenal world as a veil over the deeper reality of Brahman. Maya is not an illusion in the sense of being fake. It is an illusion in the sense that it presents a partial, observer-dependent view of a reality that is more complete than any observer can perceive from within the veil. You see the world as a collection of separate objects because Maya structures your perception that way. But the reality behind Maya, the reality of Brahman, is undivided, infinite, and not constrained by the boundaries that Maya imposes. The event horizon of Maya is the boundary between the phenomenal world and the ground of being. In Buddhism, the Heart Sutra contains the most famous statement of this principle: form is emptiness. Emptiness is form. The phenomenal world form is not separate from the ultimate nature of reality emptiness. They are identical, seen from different perspectives. From outside the veil of conventional perception, you see form solid objects, separate entities, a world of diversity and multiplicity. From inside the veil, you see emptiness, the interconnected, boundaryless, undivided nature of reality as it actually is. The veil is not a barrier between two different things. It is the difference between two ways of seeing the same thing. Exactly as the event horizon is not a barrier between two different spaces, it is the difference between two ways of observing the same space-time. The Kabbalistic tradition offers yet another parallel. In Kabbalah, the Ein Sof, the infinite, is completely unknowable from within the created world. No finite mind can perceive the Ein Sof directly, because the act of perception requires a boundary between perceiver and perceived, and the Ein Sof has no boundary. The Sephirot, the 10 divine emanations, are the structures through which the Ein Sof makes itself knowable. They are the veils, the filters, the event horizons of consciousness through which infinite reality is translated into finite experience. Each sephirah reveals one aspect of the divine, while concealing the totality. And the deepest Kabbalistic practice contemplation of the Ein Sof through the sephirot is, structurally, the attempt to see past the event horizon of created reality into the infinite ground that lies beyond it. The Tibetan Buddhist tradition adds a specific practice dimension. In Dzogchen, the practitioner is taught to look directly at the nature of mind itself, not at thoughts, not at perceptions, not at emotions, but at the awareness that is aware of all of these. This is described as looking into the mirror rather than at the reflections in the mirror. The reflections are the phenomenal world, the forms, the events, the objects of experience. The mirror is awareness itself, the ground from which all reflections arise and into which they dissolve. To look at the mirror is to look past the event horizon of ordinary perception into the nature of consciousness itself. And what the tradition reports finding there is not darkness, not nothingness, not the void that the word black hole might suggest. It is luminosity, a brightness that is the nature of awareness, prior to all content, prior to all form, prior to all the reflections that usually occupy it. What we are beginning to see is that the black hole, far from being a mere astrophysical curiosity, may be the physical universe's most precise embodiment of a principle that runs through the deepest levels of both physics and contemplative thought. That reality is observer-dependent, that boundaries are perspectival rather than absolute, and that what you see when you look at the universe depends fundamentally on where you are standing when you look. The black hole is a mirror, not in the trivial sense that it reflects light, it does the opposite, but in the profound sense that what it shows you depends on who you are. The outside observer sees a frozen boundary, an impenetrable veil, an object from which no information escapes. The inside observer sees transparent space, an unremarkable passage, a continuation of the same reality that existed before the crossing. The black hole does not have a single nature. It has a nature that changes depending on the observer's relationship to it. It reflects back to each observer a different version of reality, shaped by the observer's own position. This is why the title of this investigation calls the event horizon a mirror horizon. The event horizon does not show you the black hole. It shows you your own relationship to reality. It shows you that what you call the world is not an objective, observer-independent fact. It is a perspectival construction that depends on where you stand, how you look, and what kind of entity you are. The physicist sees space-time curvature. The Sufi sees veils of light and darkness. The Buddhist sees the boundary between form and emptiness. The Kabbalist sees the sephirot filtering the infinite. They are all looking at the same structure, the boundary between what can be observed and what lies beyond observation, and they are all seeing it through the lens of their own investigative tradition. The black hole does not care which tradition you bring to it. It reflects them all, because it embodies the principle that all of them describe, that reality has an inside and an outside, that the boundary between them is observer-dependent, and that the deepest truths lie not on either side of the boundary, but in understanding the nature of the boundary itself. In the next stage of this investigation, we will enter the crisis that erupts when quantum mechanics meets the event horizon. Because the observer dependence of the event horizon is not just a philosophical curiosity, it is the source of the most important unsolved problem in theoretical physics, the black hole information paradox. And the resolution of that paradox may tell us something extraordinary about the nature of consciousness, the fate of information at the boundaries of reality, and the question of whether the universe has an inside and an outside, or whether inside and outside, like form and emptiness, like the observer and the observed, are two ways of looking at the same thing. The event horizon is where physics meets its own limits. It is where equations produce contradictions, where the known laws of nature generate paradoxes, where the deepest theories of the 20th century collide and break. But it is also where the most profound questions about the nature of observation, information, and consciousness converge into a single, inescapable challenge. The black hole does not merely test our physics. It tests our understanding of what it means to observe, what it means to know, and what it means to exist on one side of a boundary that defines what can and cannot be seen. The mirror is dark, but what it reflects may be the most illuminating truth that physics has ever uncovered. In 1974, Stephen Hawking made a discovery that shattered the foundations of theoretical physics and ignited a war among the greatest minds in science that lasted 30 years. The discovery was simple to state and devastating in its implications. Black holes are not black. They glow, they radiate energy, they evaporate, and when they do, they may destroy something that the laws of physics say cannot be destroyed. The story begins with Hawking's attempt to apply quantum mechanics to the event horizon of a black hole. Classical general relativity describes the event horizon as a smooth, featureless boundary, but quantum mechanics says that no region of space is ever truly smooth or featureless. The vacuum seethes with virtual particle pairs, particle-antiparticle pairs, that pop into existence from the energy of the quantum vacuum, exist for an unimaginably brief moment, and then annihilate each other and vanish. This happens everywhere in the universe, constantly, at every point in space. It is the quantum foam that underlies the apparent smoothness of reality. Hawking realized that something extraordinary happens when this process occurs at the event horizon of a black hole. The intense gravitational field at the horizon can rip a virtual particle pair apart before the two particles have a chance to annihilate. One particle falls into the black hole, the other escapes into space as real physical radiation. From the perspective of a distant observer, the black hole is emitting particles. It is glowing, and since the escaping particle carries energy, and since energy must be conserved, the black hole must lose a corresponding amount of energy. It loses mass. It shrinks. Over time, an inconceivably long time for a stellar mass black hole, but a finite time nonetheless, the black hole evaporates completely. It radiates away all of its mass and vanishes, leaving behind nothing but a faint bath of thermal radiation. This is Hawking radiation, and it is one of the most important theoretical results in the history of physics. It connects general relativity, quantum mechanics, and thermodynamics in a single phenomenon. It shows that black holes have a temperature, an incredibly low temperature for large black holes, but a temperature that increases as the black hole shrinks, accelerating the evaporation process in a runaway cascade that ends in a final burst of radiation as the last remnant of the black hole disappears. Black holes are not eternal. They are born, they live, and they die, just like stars, just like people, just like everything else in the universe. Hawking's discovery also revealed a deep connection between black holes and thermodynamics. In 1972, Jacob Bekenstein had proposed that black holes have entropy, that they are not simple, featureless objects, but enormously complex systems with a huge number of internal states. Bekenstein showed that the entropy of a black hole is proportional to the surface area of its event horizon, not to its volume. This was shocking. For every other physical system in the universe, entropy is proportional to volume. A box of gas has entropy proportional to the volume of the box. A star has entropy proportional to its volume. But a black hole has entropy proportional to its surface area. The information content of a black hole lives on its surface, not in its interior. This was the first hint of holography, the first indication that the three-dimensional interior of a black hole might be fully described by the two-dimensional surface of its event horizon. Bekenstein's formula, confirmed and refined by Hawking's work, tells us that a black hole with an event horizon surface area of 1 square Planck length, the smallest meaningful area in physics. Approximately 10 to the minus 70 square meters contains exactly 1 bit of information. 1 square Planck length, 1 bit. The event horizon is a hard drive, and the information density is the maximum that the laws of physics permit. No other physical system can store more information per unit area than a black hole's event horizon. The total information content of a solar mass black hole is approximately 10 to the power of 77 bits. For comparison, the total information content of the observable universe, stored in all the matter and radiation that we can detect, is estimated at approximately 10 to the power of 90 bits. A single supermassive black hole at the center of a galaxy can contain a significant fraction of the total information in its entire cosmic neighborhood. Black holes are not just gravitational objects. They are the universe's supreme information processors, objects that compress, encode, and store information with a density and efficiency that no other system in nature can match. But Hawking radiation created a problem that is far more profound than the mere mortality of black holes. The problem concerns information. In physics, information is not a vague concept. It has a precise, technical meaning. The information content of a physical system is a complete description of the system's quantum state, the totality of data needed to reconstruct the system exactly as it is. Every particle in the universe has a quantum state. Every collection of particles has a joint quantum state. And the laws of quantum mechanics, specifically the principle of unitarity, guarantee that this information is conserved. It can be transformed, scrambled, redistributed, and encoded in forms that are unrecognizable to any practical measurement. But it cannot be destroyed. This is not an optional feature of quantum mechanics. It is built into the mathematical structure of the theory at the deepest level. If unitarity fails, quantum mechanics fails. And quantum mechanics does not fail. It is the most precisely tested theory in the history of science. Now consider what happens when an object falls into a black hole, and the black hole subsequently evaporates through Hawking radiation. The object, say, a book, carries information, the positions of its atoms, the arrangement of its molecules, the content written on its pages, the quantum state of every particle that composes it. All of this information crosses the event horizon and enters the black hole. The black hole then evaporates, emitting Hawking radiation. But Hawking's original calculation showed that the radiation is thermal. It is random, featureless, and carries no information about what fell into the black hole. A black hole that swallowed a book emits the same radiation as a black hole that swallowed an equivalent mass of random gas. The specific information contained in the book, the quantum state that distinguished it from any other object of the same mass, appears to be permanently lost. Think about what this means. If Hawking's original calculation was correct, the universe has a mechanism for permanently erasing information. A book can be burned, and you could in principle reconstruct it from the ashes and the smoke. But a book that falls into a black hole and waits for the black hole to evaporate is gone, not transformed, not encoded, not scrambled, but annihilated. Its information has been deleted from reality, permanently and irreversibly. This is not like any other physical process. In every other process in the universe, combustion, dissolution, radioactive decay, even nuclear annihilation, information is preserved. The process is reversible in principle, even when it is irreversible in practice. But black hole evaporation, as Hawking originally described it, is irreversible in principle. The information is not merely inaccessible, it ceases to exist. If this were true, it would have consequences far beyond black hole physics. It would mean that the universe has a trapdoor, a mechanism for permanently deleting parts of its own history. Events that fell into black holes would be not just hidden but erased. The past would be, in a precise physical sense, destroyable. The laws of physics would not merely permit forgetting, they would mandate it. This is the black hole information paradox, and it is not a minor puzzle. It is a direct contradiction between the two foundational theories of modern physics. General relativity says that information can cross the event horizon and fall into the singularity. Quantum mechanics says that information cannot be destroyed. If the black hole evaporates and the information is gone, then either general relativity is wrong about what happens at the event horizon, or quantum mechanics is wrong about the conservation of information. One of them must break. And since both of them are supported by overwhelming experimental evidence, no one knew which one to sacrifice. The physics community split into two camps. Hawking, along with many general relativists, argued that information is genuinely destroyed when a black hole evaporates. This would require modifying quantum mechanics at a fundamental level, a radical step, but one that Hawking was willing to take. On the other side, Leonard Susskind, Gerard Hooft, and most of the quantum mechanics and string theory community argued that information cannot be destroyed under any circumstances, and that Hawking's calculation must be missing something, some mechanism by which the information is encoded in the Hawking radiation in a form too subtle for Hawking's original analysis to detect. The debate lasted 3 decades. It was, by all accounts, one of the most intense and productive intellectual confrontations in the history of physics. Susskind has described it as a war fought with equations instead of weapons, but a war nonetheless, with the fundamental nature of reality as the prize. In 2004, Hawking conceded. At a conference in Dublin, he announced that he had been wrong, that information is not destroyed by black holes, and that the information must somehow be encoded in the Hawking radiation. He presented a new calculation, based on the path integral formulation of quantum gravity, that suggested the information escapes through quantum correlations in the radiation that his original calculation had overlooked. The concession was dramatic and widely reported, but the underlying mechanism, exactly how the information gets out, remained unclear. Hawking had conceded the battle but not explained the victory. The concept of information scrambling became central to understanding how the information escapes. The physicist Patrick Hayden and the information theorist John Preskill showed that black holes are the fastest scramblers in nature. They take incoming information and distribute it across their entire quantum state faster than any other physical system. The scrambling time for a black hole is logarithmic in its entropy, which means that even a supermassive black hole scrambles information in a time that is astonishingly short by astronomical standards. The information is not hidden. It is redistributed, spread across the quantum correlations of the Hawking radiation, in a pattern so complex that no practical measurement could reconstruct it, but that is, in principle, fully recoverable. This is analogous to burning an encyclopedia. The information in the encyclopedia is not destroyed by the fire. It is encoded in the correlations between the smoke particles, the ash, the infrared radiation, and the convection currents. In principle, if you could track every particle of smoke and measure every photon of infrared radiation, you could reconstruct the encyclopedia. In practice, this is impossible, but the information is there. It has not been annihilated, it has been scrambled. A black hole does the same thing, but with quantum mechanical precision. The information that falls in is scrambled across the Hawking radiation, with a complexity that is exponential in the black hole's entropy. Decoding it would require quantum computers of a size and power that will never exist. But the laws of physics guarantee that the information is preserved, that nothing that falls into a black hole is ever permanently lost. The explanation came from an unexpected direction: holography. In 1993, Gerard Hooft proposed a radical idea that Leonard Susskind subsequently developed into a comprehensive framework. The idea was that the information content of any three-dimensional region of space can be fully encoded on the two-dimensional boundary of that region. This is the holographic principle, and it says that the universe is, in a precise mathematical sense, a hologram, a three-dimensional image projected from a two-dimensional surface. The way a holographic image on a credit card appears to have depth, even though all the information is stored on a flat surface. Applied to black holes, the holographic principle resolves the information paradox in a stroke. The information that falls into a black hole is not lost inside the three-dimensional interior. It is encoded on the two-dimensional surface of the event horizon. Every bit of information that has ever crossed the event horizon is recorded there, like writing on a cosmic blackboard. And when the black hole evaporates through Hawking radiation, the information is released from the surface, encoded in subtle quantum correlations in the radiation. Nothing is lost. The information is merely transformed from its original form inside the falling object to a scrambled, encoded form on the event horizon, and then to an even more scrambled form in the Hawking radiation. But it is all there. Unitarity is preserved. Quantum mechanics survives. In 1997, the physicist Juan Maldacena provided the most powerful evidence for the holographic principle with his discovery of the ADS CFT correspondence, a mathematical equivalence between a theory of gravity in a higher dimensional space and a quantum field theory without gravity on the lower dimensional boundary of that space. Maldacena showed that everything that happens in the interior of the higher dimensional space, including the formation and evaporation of black holes, can be fully described by the boundary theory, which does not contain gravity and which manifestly preserves information. The interior physics and the boundary physics are two descriptions of the same reality, and since the boundary description preserves information, the interior description must preserve it too, even when black holes form and evaporate. The ADS CFT correspondence is widely regarded as the most important result in theoretical physics in the past 30 years. It has been tested in thousands of calculations and has never produced a contradiction. It provides strong evidence, though not mathematical proof, that the holographic principle is correct, and that information is never destroyed, not even by black holes. But the resolution of the information paradox created new problems that are, in some ways, even more disturbing. In 2012, 4 physicists, Ahmed Almheri, Donald Marolf, Joseph Polchinski, and James Sully, collectively known as AMPS, published a paper that reignited the black hole crisis. They showed that the holographic resolution of the information paradox is incompatible with another cherished principle of physics, the equivalence principle, which states that an observer crossing the event horizon of a sufficiently large black hole should notice nothing unusual. According to AMPS, if the information is encoded on the event horizon and released through quantum correlations in the Hawking radiation, then the event horizon cannot be the smooth, harmless boundary that general relativity predicts. Instead, it must be a firewall, a sheet of high-energy radiation that incinerates anything that attempts to cross it. The firewall paradox presented physicists with an impossible choice among 3 principles, all of which are deeply embedded in the foundations of physics. Unitarity, information is conserved. Equivalence, the event horizon is smooth for a falling observer. And the validity of quantum field theory in regions of low curvature. AMPS showed that all 3 cannot be simultaneously true. At least one of them must fail at the event horizon. And since each one is supported by extensive evidence and plays a foundational role in our understanding of physics, giving up any one of them is deeply disturbing. The firewall paradox struck at the heart of what physicists thought they understood about black holes. For 40 years, since Hawking's original discovery, the consensus had been that an observer falling through the event horizon of a large black hole would experience nothing unusual, that the equivalence principle guaranteed a smooth passage. The AMPS paper destroyed this consensus. If information is preserved and encoded in the Hawking radiation, then the event horizon cannot be the innocent boundary that Einstein's equations describe. Something dramatic must happen there, either a firewall that destroys the falling observer, or some radical modification of our understanding of space-time, information, or both. The crisis is not merely technical, it is conceptual. It forces us to confront a question that physics has been avoiding for a century. What is the relationship between information and experience? If the information that constitutes a falling observer is preserved on the event horizon, but the observer's experience of falling through is smooth and continuous, then which description is more fundamental? The informational description on the boundary or the experiential description in the interior? Are they two aspects of the same reality, like the wave and particle descriptions of light? Or is one of them an illusion generated by the other? The firewall paradox remains unresolved. Multiple proposed solutions have been offered, and none has achieved consensus. Susskind and Maldacena proposed ER equals EPR, the idea that the quantum entanglement between the Hawking radiation and the interior of the black hole is physically realized as a wormhole, an Einstein-Rosen bridge connecting the interior to the radiation through the geometry of spacetime itself. If ER equals EPR is correct, then the interior of the black hole is not disconnected from the exterior. It is connected through the wormhole, and the firewall does not form, because the entanglement is maintained through the geometric connection. This is an elegant proposal, and it has generated enormous excitement, but it has not been proven, and the firewall paradox remains open. What does all of this mean for our question about consciousness? The question is more precise than it might appear. The black hole information paradox is not just about abstract bits of data. It is about what happens to the physical systems that carry information, including brains, including neurons, including the quantum states that may constitute conscious experience. If a conscious being falls into a black hole, the information paradox becomes the consciousness paradox. What happens to the experience of the falling observer? From the outside, the observer is frozen at the event horizon, their information smeared across the surface in a holographic encoding. From the inside, the observer continues to experience, to see, to feel, to think as they fall through the horizon and approach the singularity. Two descriptions of the same consciousness in two different locations at two different stages of existence. Both are valid according to the current understanding of physics, and the question of which one is more real, the holographic ghost on the surface or the experiencing subject in the interior, is, at its core, a question about the nature of consciousness itself. This is called black hole complementarity, proposed by Susskind, Thorlacius, and Uglum in 1993. It states that both descriptions are correct, but no single observer can access both simultaneously. The outside observer sees the holographic encoding. The inside observer experiences the smooth interior, and there is no contradiction because no experiment can be performed that would reveal both descriptions to the same observer. Complementarity is not a resolution of the paradox. It is a statement that the paradox arises from the false assumption that reality must be described in a single, observer-independent way. At the event horizon, reality is observer-dependent in the most radical sense possible. The information paradox and its holographic resolution tell us something profound. Information is the most fundamental currency of physical reality, and it cannot be destroyed under any circumstances. The laws of physics do not permit it. The universe will rearrange space-time geometry, create wormholes, project three-dimensional interiors from two-dimensional surfaces, and do whatever else is necessary to ensure that information is never lost. Now apply this to consciousness. If consciousness is information, If the subjective experience of a conscious being is constituted by the integrated information in their brain, as Tononi's IIT proposes, then the information that constitutes consciousness cannot be destroyed by a black hole, any more than the information in a book can be destroyed. It can be scrambled, encoded, and redistributed in forms that are unrecognizable, but it cannot be annihilated. The holographic principle guarantees that every bit of information that crosses the event horizon is preserved on the surface. If you fell into a black hole, the information that constitutes your consciousness would be encoded on the event horizon, transformed beyond recognition, but not destroyed. This connects directly to a question we explored in our investigation of death. If consciousness is information, and if quantum information is conserved, then what happens to conscious experience when the physical system that hosts it is destroyed? The black hole is the most extreme version of this question. A black hole does not merely destroy the brain, it destroys the atoms that compose the brain, the particles that compose the atoms, and the space-time that contain the particles. It is the most thorough destruction that the laws of physics permit. And yet, even this ultimate destruction does not destroy the information. The holographic principle says it is all still there, encoded on the boundary. The Sufi tradition describes this principle with an image that could have been drawn from a physics textbook. Ibn Arabi writes that every manifest form in the created world is a reflection of a divine name inscribed on the preserved tablet, the Lawh al-Mahfuz. The tablet contains the complete information about everything that has ever existed, that exists now, and that will ever exist. Nothing is ever lost from the tablet. Forms appear and disappear in the physical world, but their informational essence, their pattern, their meaning, their identity is permanently preserved on the tablet. The preserved tablet is, in structure, exactly what the holographic principle describes: a lower dimensional boundary surface on which the complete information content of the higher dimensional reality is permanently encoded. In Judaism, the concept of divine memory serves a similar function. The Talmud teaches that God remembers everything, every deed, every word, every thought, every moment of every life that has ever been lived. Nothing is forgotten, nothing is erased. The divine memory is the ultimate information preservation system, a repository from which nothing is ever lost and from which everything can, in principle, be retrieved. The Day of Judgment, in Jewish eschatology, is the moment when the complete informational record of every life is reviewed, not reconstructed from fragmentary evidence, but accessed directly from the divine memory in which it has been preserved in its entirety. The information was never lost. It was always there, on the boundary of divine awareness, waiting to be read. The Christian tradition offers a parallel in the concept of the Book of Life, described in the Book of Revelation. Every name, every deed, every thought is recorded in a book that is not subject to the decay and destruction of the physical world. The book preserves information eternally, independent of the physical forms that originally carried it. The destruction of the body does not erase the name from the book. The information persists beyond the destruction of its physical substrate. In Buddhism, the concept of the alaya vijnana, the storehouse consciousness, serves a similar function. The alaya vijnana is a level of consciousness that stores the seeds of all experiences, all actions, all karmic imprints. These seeds are not destroyed when the individual consciousness dissolves at death. They are preserved in the storehouse, where they can ripen into future experiences in future lives. The alaya vijnana is, functionally, an information preservation mechanism that ensures continuity of consciousness across the destruction of individual physical forms, a biological, holographic principle operating at the level of consciousness rather than the level of space-time geometry. In Hinduism, the concept of the Akashic record describes a cosmic repository of all information, every event, every thought, every experience that has ever occurred in the history of the universe, permanently encoded in the fabric of reality itself. The Akashic record is not a metaphor. In Hindu metaphysics, it is a literal feature of the cosmos, a field of information that pervades all of space and all of time, and that preserves the complete history of everything that has ever happened. Theosophical traditions later adopted and elaborated this concept, but its roots are in the Vedic understanding of Akasha, the fundamental space, or ether, that underlies all physical manifestation and that retains the informational imprint of everything that occurs within it. The convergence is now unmistakable. Physics tells us that information cannot be destroyed, even by the most extreme processes in the universe. The holographic principle tells us that information is preserved on boundaries, encoded in forms that transcend the three-dimensional reality we inhabit. And the contemplative traditions, independently and across every major civilization, describe information preservation mechanisms: the preserved tablet, the book of life, the storehouse consciousness, the Akashic record, that serve exactly the same function, ensuring that nothing that has ever existed is permanently lost. If consciousness is information, and if information is indestructible, then consciousness is indestructible, not necessarily in the form that you currently experience it. Not as the specific personality, the specific memories, the specific narrative self that you identify as you, but as information, as the pattern, the structure, the integrated data that constitutes the subjective experience of being aware. That information, according to the deepest principles of physics, cannot be annihilated. It can be transformed. It can be scrambled. It can be encoded in forms that no instrument can currently read. But it cannot be destroyed, not by death, not by time, not even by a black hole. This is perhaps the most profound conclusion that physics has reached in the past half-century. The universe is structured to preserve information absolutely, not approximately, not in most cases. Absolutely, in every case, under every circumstance, even in the most extreme gravitational environments that exist. The laws of physics are, at their deepest level, laws of memory. The universe does not forget, and if consciousness is a form of information, if the experience of being aware is constituted by the pattern, the structure, the integrated data of a conscious system, then the universe does not forget consciousness either. It cannot. Its own laws forbid it. In the next stage of this investigation, we will explore the most radical implication of the holographic principle, that we ourselves may be living on the boundary of something we cannot see, that the three-dimensional world we experience may be a holographic projection from a surface we cannot access, and that the event horizon of a black hole may not be a distant astrophysical phenomenon. It may be a mirror, a reflection of the very structure of the reality we inhabit, showing us that the boundary between inside and outside, between self and world, between consciousness and its objects, is not what we think it is. We have now established two extraordinary facts about black holes. First, the event horizon is a boundary where reality becomes observer-dependent in the most radical way physics has ever described. Two observers, looking at the same event, see two completely different physical realities. Second, the information that falls into a black hole is not destroyed, but preserved, encoded on the two-dimensional surface of the event horizon, in a holographic form that contains every detail of the three-dimensional interior. The black hole is not a destroyer of information. It is a transformer of information, a cosmic encoder that takes the three-dimensional reality of falling objects and compresses it into a two-dimensional record on the boundary. Now we must follow these facts to their most radical destination, because the holographic principle does not apply only to black holes. It applies to the entire universe, and its implications for the nature of reality, the structure of consciousness, and the relationship between the observer and the observed are so profound that they may constitute the deepest insight that physics has ever produced. The argument begins with a remarkable coincidence, a coincidence that most cosmologists believe is not a coincidence at all. The observable universe has a boundary. It is called the cosmic horizon, or the particle horizon, and it is the maximum distance from which light has had time to reach us since the Big Bang. Because the universe is 13.8 billion years old and light travels at a finite speed, there is a limit to how far we can see. Beyond that limit, light has not had time to arrive. The cosmic horizon is currently approximately 46 billion light years away in every direction, forming a sphere around us that contains everything we can observe, detect, or interact with. Beyond the horizon, the universe presumably continues, but we have no way of knowing what is there. No signal, no particle, no information from beyond the cosmic horizon can reach us. It is, for all practical and physical purposes, the edge of our reality. Here is the coincidence. The cosmic horizon has exactly the same mathematical structure as the event horizon of a black hole. Both are boundaries from which information cannot escape. Both define a region that is causally disconnected from the observer. Both have an associated entropy that is proportional to the surface area of the boundary, not to the volume of the region they contain. And both produce thermal radiation. The cosmic horizon produces a faint glow called the Gibbons-Hawking radiation, analogous to Hawking radiation from a black hole, caused by the same mechanism of vacuum fluctuations at the boundary. The physicist Ted Jacobson demonstrated in 1995 that Einstein's equations of general relativity, the equations that describe the curvature of space-time and the behavior of gravity, can be derived from the equations. Thermodynamics of the cosmic horizon. He showed that if you assume that the entropy of the horizon is proportional to its area and that the laws of thermodynamics hold at the boundary, then Einstein's equations follow as a mathematical consequence. This is an astonishing result. It means that gravity is not a fundamental force. It is an emergent phenomenon, a consequence of the way information is organized on the boundaries of space-time. Gravity is what information does when it is encoded on a surface. Jacobson's result is often underappreciated, but it may be one of the most important papers in the history of physics. For a century, physicists have treated Einstein's equations as fundamental as the bedrock description of how gravity works. Jacobson showed that they are not fundamental. They are thermodynamic. They describe the macroscopic behavior of a deeper, microscopic system, the way the gas law PV equals nRT describes the macroscopic behavior of trillions of individual gas molecules. You do not need to know about individual molecules to use the gas law, and you do not need to know about the microscopic structure of space-time to use Einstein's equations. But just as the gas law emerges from the statistical behavior of molecules, Einstein's equations emerge from the statistical behavior of information on the boundary of space-time. Gravity is not a fundamental force. It is a statistical effect. It is what information does when there is a lot of it. This means that space-time itself, the arena in which all physics takes place, the stage on which the drama of the universe unfolds, is not fundamental. It is emergent. It arises from something more basic, something that does not have the properties of space and time, something that is better described as information organized on a boundary than as a three-dimensional volume with geometric properties. The stage is not given in advance and then populated with actors. The stage and the actors emerge together from the same underlying informational code. The physicist Erik Verlinde at the University of Amsterdam extended Jacobson's work in 2010 with his entropic gravity proposal. Verlinde argued that gravity is an entropic force, a force that arises from the tendency of systems to maximize their entropy the way a rubber band tends to contract because contracted configurations have higher entropy than stretched configurations. In Verlinde's framework, the gravitational attraction between two masses is not caused by the exchange of gravitons or the curvature of spacetime. It is caused by the holographic information on the boundary between them rearranging itself to maximize entropy. Mass tells the boundary how to rearrange its information. The rearrangement of information tells mass how to move. Gravity is the universe's information management system. If these ideas are correct, and they are supported by a growing body of theoretical work, though they remain controversial, then the holographic principle is not just a property of black holes. It is a property of the universe. The three-dimensional world you inhabit is a holographic projection from a two-dimensional boundary. Every object you see, every person you touch, every event you experience is a projection from information encoded on the cosmic horizon, a surface that you will never reach, never touch, never see, but that contains, in its two-dimensional code, everything that constitutes your three-dimensional reality. You are a hologram, not metaphorically, not approximately. If the holographic principle is correct, the three-dimensional space you occupy is not fundamental. It is emergent. It is projected from a lower dimensional surface that is, in a precise mathematical sense, more real than the three-dimensional world it generates. The depth you perceive, the solidity you feel, the extension in space that your body occupies, all of it is a three-dimensional rendering of two-dimensional data, the way a holographic image on a credit card appears to have depth, even though all the information is stored on a flat surface. Consider what this means for your daily experience. The coffee cup on your desk appears to be a solid, three-dimensional object occupying a specific volume of space. But if the holographic principle is correct, the cup is a three-dimensional rendering of two-dimensional information. Its depth, its solidity, its spatial extension, all of these are properties of the rendering, not of the underlying code. The cup is real in the same way that a character in a perfectly rendered video game is real. It has measurable properties. It interacts with other objects according to consistent rules. It behaves predictably. But it is not what it appears to be. Its apparent three-dimensionality is a projection from a lower dimensional information source that does not have the properties of depth and volume. Your body is the same. The neurons in your brain, the synapses through which your thoughts propagate, the chemical reactions that underlie your emotions, all of them are three-dimensional projections from two-dimensional information. The brain you identify with, the body you inhabit, the space you move through, all projections, all holograms, all renderings of a code that exists at a level of reality that does not have the spatial properties you take for granted. This is not speculation from the fringe of physics. The holographic principle is one of the most active and most productive areas of research in theoretical physics today. The ADES CFT correspondence, which provides the strongest evidence for holography, has been cited over 20,000 times and has generated an entire subfield of mathematical physics. The entropic gravity program has produced testable predictions that are being compared with astronomical observations. And the idea that space-time itself is emergent, that it is woven from quantum entanglement and projected from information on a boundary, is now a mainstream research direction pursued by leading groups at Stanford, MIT, Princeton, the Institute for Advanced Study, and universities around the world. But here is where the physics becomes truly extraordinary, because the holographic principle does not just tell us about the structure of space, it tells us something about the nature of observation itself. If the three-dimensional world is a projection from a two-dimensional boundary, then your experience of three-dimensional reality is an experience of a projection. Your consciousness does not inhabit a three-dimensional space. It experiences a three-dimensional image that is generated by two-dimensional information. The space you feel around you, the room you sit in, the sky above you, the The distance between you and the objects you see is not the fundamental reality. It is a representation, a rendering, a projection from a more fundamental level of reality that does not have the spatial properties you take for granted. This has a direct and profound implication for the nature of distance and separation. In the three-dimensional projection, objects are separated by space. You are here, the wall is there. The star is far away. But in the two-dimensional code from which this projection is generated, the concept of spatial distance does not apply in the same way. The information that corresponds to you and the information that corresponds to the wall are not separated by three-dimensional space on the boundary. They are encoded in a two-dimensional pattern in which the metric, the measure of distance, is fundamentally different from the three-dimensional metric you experience. Things that appear far apart in the projection may be close together in the code. Things that appear separate in 3 dimensions may be aspects of a single, unified data structure on the boundary. Mark van Ramsdonk, the physicist whose work we encountered in our investigation of quantum entanglement, has argued that the 3-dimensional space we experience is literally made of entanglement. In his framework, the spatial distance between 2 points in the projected 3-dimensional world is a measure of the entanglement between the corresponding regions on the 2-dimensional boundary. Regions that are highly entangled on the boundary appear close together in the projection. Regions that are weakly entangled appear far apart. And if the entanglement between 2 regions is removed entirely, the corresponding regions of 3-dimensional space disconnect. They pinch off from each other, creating a rupture in the fabric of space itself. Space is made of entanglement. Distance is a measure of quantum correlation, and the 3-dimensional world is a map of the entanglement structure of a 2-dimensional boundary code. This is Van Ramsdonk's thesis, and it has become one of the most influential ideas in contemporary theoretical physics. The physicist Ahmed Almhiri, one of the authors of the AMPS firewall paper along with Shi Dong and Daniel Harlow, has shown that the holographic code has the structure of a quantum error-correcting code. In classical computing, error-correcting codes protect information against damage by encoding it redundantly. If some bits are lost or corrupted, the information can be reconstructed from the remaining bits. Quantum error-correcting codes do the same thing for quantum information, protecting fragile quantum states against decoherence and noise. Almhiri, Dong, and Harlow showed that the holographic code is exactly such a quantum error-correcting code. The 3-dimensional interior of a region of space-time is encoded redundantly on the 2-dimensional boundary in such a way that any small portion of the boundary can be lost without losing the information about the interior. The hologram is robust. It can be damaged, and the 3-dimensional world it projects will still be reconstructed accurately. This is why the physical world appears stable and solid. Despite being a projection from an informational surface, the projection is protected by the same mathematical structure that protects quantum information in a quantum computer. This discovery has profound implications. It means that the 3-dimensional world is not just a projection, it is a protected projection, an error-corrected rendering of boundary information that is designed by the mathematical structure of the code to be stable, reliable, and resistant to perturbation. The universe is not a fragile hologram that could flicker out at any moment. It is a robustly encoded hologram, protected by the deepest mathematical structures that quantum mechanics possesses. Now, bring this back to black holes. A black hole is a region where the entanglement structure has been reorganized so drastically that the interior becomes disconnected from the exterior, or rather, connected only through the event horizon, where the information is encoded. The ER equals EPR conjecture tells us that this connection is maintained through a wormhole, a tunnel in space-time that links the interior to the exterior through the entanglement between the Hawking radiation and the black hole's quantum state. The black hole is not a hole in the fabric of space. It is not a region where the entanglement structure has been tied so tightly that the projection algorithm generates a singularity instead of smooth space. And here is the insight that transforms our understanding. If black holes are knots in the entanglement structure of the holographic code, and if the entire universe is a holographic projection from a two-dimensional boundary, then every feature of the three-dimensional world, every object, every distance, every spatial relationship, is a feature of the entanglement structure on the boundary. The universe is not a container in which things exist. The universe is a pattern of entanglement that generates the experience of things existing in a container. This is where the contemplative traditions become not just relevant but essential. Because the traditions have been saying something structurally identical for millennia, using the language of consciousness rather than the language of information theory. In Hinduism, the doctrine of Maya, which we have encountered in every investigation in this series, acquires its deepest significance in the holographic context. Maya is not merely the claim that the world is an illusion. It is the claim that the world as we perceive it is a projection from a more fundamental level of reality that does not have the properties we attribute to the projection. The three-dimensional world of separate objects, extended spaces, and temporal flow is not the deepest reality. It is a manifestation, a rendering of a reality that is non-spatial, non-temporal, and undivided. The Mandukya Upanishad's description of Turiya, the fourth state of consciousness that transcends waking, dreaming, and deep sleep is, in the holographic framework, a description of consciousness apprehending the boundary code directly, rather than the three-dimensional projection that the code generates. Turiya is the experience of seeing the hologram from behind the screen, rather than from in front of it. The Hindu concept of Indra's net provides an even more precise metaphor for the holographic principle. In the Atharva Veda and later Buddhist elaborations, Indra's net is described as an infinite web of jewels, each jewel positioned at a node of the net. Each jewel reflects every other jewel perfectly, and each reflection contains reflections of all the other jewels, and each of those reflections contains further reflections, infinitely. There is no original and no copy. Every jewel contains the entire net. Every point contains the whole. This is a remarkably precise description of the holographic principle's most counterintuitive property: non-locality of information. In the holographic code, the information about any region of the interior is not localized in a single region of the boundary. It is distributed across the entire boundary. Every part of the boundary contains information about the whole interior, and if you examine any sufficiently large portion of the boundary, you can reconstruct the entire three-dimensional interior. Every part contains the whole. Every jewel reflects the net. The ancient myth and the modern physics describe the same informational structure. The Buddhist Heart Sutra's declaration that form is emptiness, emptiness is form, is a precise description of the holographic relationship between the three-dimensional projection and the two-dimensional code. The forms we perceive, objects, bodies, spatial extensions, are empty of inherent, independent existence. They are projections. They do not have the self-sustaining solidity that we attribute to them, but emptiness is not nothing. Emptiness is the boundary code, the two-dimensional informational ground from which the forms are projected. Form is emptiness because the three-dimensional projection has no independent reality apart from the code. Emptiness is form because the code manifests as the three-dimensional projection. They are two descriptions of the same reality, seen from two different levels, exactly as the holographic principle describes. The Sufi concept of barzakh, the isthmus, the in-between, describes a level of reality that is neither the divine ground nor the physical world, but the interface between them. Ibn Arabi describes barzakh as the realm of images, the level at which the formless divine reality takes on form. the level at which the infinite becomes finite, the level at which the undifferentiated ground is differentiated into the multiplicity of created things. The barzakh is, structurally, the boundary surface of the holographic principle, the two-dimensional interface between the undifferentiated ground state and the three-dimensional projection that we experience as the physical world. It is the screen on which the hologram is generated. It is the surface that contains all the information. And it is, in Sufi contemplative practice, the level of reality that the mystic learns to perceive directly, seeing through the three-dimensional projection to the informational code from which it arises. In Christianity, the Platonic influence on early Christian theology produced a framework that is remarkably compatible with holographic cosmology. Plato's allegory of the cave describes prisoners who see only shadows on a wall and mistake them for reality. The true objects, the forms that cast the shadows, are behind them, in a higher level of reality that they cannot perceive. The prisoners live in a projected world, taking the projection for the real thing. Christian Neoplatonists like Pseudo-Dionysius and John Scotus Eriugena developed this into a comprehensive theology in which the physical world is an emanation from a higher divine reality, a projection from the mind of God into the lower dimensional space of material existence. The physical world is real, but it is not the most real thing. The divine mind from which it emanates is more real, more fundamental, more ontologically basic. The physical world is to the divine mind as the holographic projection is to the boundary code, real, structured, and informative, but not self-sustaining. In the Islamic philosophical tradition, the Illuminationist school founded by Suhrawardi in the 12th century developed a metaphysics of light that maps onto the holographic framework with extraordinary precision. Suhrawardi described reality as a hierarchy of lights from the light of lights, which is God, through descending levels of luminosity down to the material world, which is the furthest from the source and the least luminous. Each level is a projection from the level above it, a less concentrated, more differentiated manifestation of the same fundamental light. The material world is not separate from God. It is God's light projected through so many levels of differentiation that it appears to be solid, spatial, and independent. But it is light all the way down, or rather, all the way up, back to the source from which it is projected. Suhrawardi's light metaphysics is not merely poetic. It is a systematic ontology that describes exactly the relationship between levels of reality that the holographic principle formalizes. The light of lights is the boundary code. The material world is the three-dimensional projection, and the hierarchy of intermediate lights is the hierarchy of informational processing that transforms the unified code into the differentiated projection. The mystic who ascends through the levels of light is doing, in contemplative practice, what the physicist does in mathematical theory, tracing the projection back to its source, reading through the hologram to the code from which it is generated. In the Kabbalistic tradition, the concept of the four worlds Atziluth, Beriah, Yetzirah, and Asaya describes a hierarchy of reality in which each lower world is a projection from the world above it. Atziluth, the world of emanation, is the closest to the divine source. Asaya, the world of action, is the physical world we inhabit. Each world is a less compressed, more differentiated rendering of the information contained in the world above it. The relationship between the worlds is not spatial. The higher worlds are not above in any physical sense. They are more fundamental, more informationally dense, more unified, more integrated. And the journey of the Kabbalist is a journey upward through the worlds, a journey from the projected, differentiated, three-dimensional world of Asaya toward the boundary code of Atziluth, where all information exists in its most concentrated and most unified form. The convergence between the holographic principle and the contemplative traditions is not superficial. It is structural. Both describe a reality with multiple levels, in which the level we ordinarily experience is a projection from a more fundamental level that is informationally richer, spatially simpler, and ontologically prior. Both describe the projection as real but not fundamental. Both identify the fundamental level with a boundary or interface that contains all the information of the projected world in a more concentrated form. And both describe practices or paths by which the observer can shift their perspective from the projection to the code, from the three-dimensional world to the two-dimensional ground, from the shadows on the wall to the light that casts them. But the holographic principle adds something that the traditions, by themselves, do not provide: a mechanism. The traditions describe what the relationship between the levels is. The holographic principle describes how it works. The mechanism is entanglement. The quantum correlations on the boundary surface are not decorations on a pre-existing space. They are the source of space. They generate the geometry, the distances, the dimensionality, and the causal structure of the three-dimensional world. Without the entanglement, there is no space. Without the correlations, there is no projection. The holographic boundary, with its pattern of quantum entanglement, is not just the code for a universe. It is the process by which a universe is continuously generated, moment by moment, correlation by correlation, bit by bit, from information into experience. This continuous generation is what the traditions call creation. Not a single event at the beginning of time, but an ongoing process that sustains reality at every instant. The Sufi concept of khalq jadid, continuous creation, in which God creates the universe anew at every moment, is the theological expression of what the holographic principle describes physically: a reality that is not static but continuously projected, continuously rendered, continuously brought into being by the informational processes on the boundary. The projection is generated by the pattern of quantum correlations on the boundary surface. Space, distance, separation, and the three-dimensional structure of the world are all emergent properties of the entanglement structure of the boundary code. And the observer your consciousness, your experience of inhabiting a three-dimensional world is part of the projection. Your consciousness is not outside the hologram, looking in. It is inside the hologram, generated by the same informational processes that generate the space around you. Or is it? Because there is an alternative possibility that the contemplative traditions have consistently advocated, and that the holographic principle does not rule out. That consciousness is not part of the projection but part of the code. That awareness is not a feature of the three-dimensional world, but a feature of the two-dimensional boundary from which the three-dimensional world is projected. That the observer is not inside the hologram, but on the surface of the hologram, part of the informational ground from which the entire three-dimensional experience is generated. This possibility is consistent with everything we have discussed in previous investigations. If consciousness is fundamental rather than emergent, as panpsychism suggests, as integrated information theory implies, as the contemplative traditions assert, then it does not belong to the projected world. It belongs to the ground from which the world is projected. It is not a feature of the three-dimensional space. It is a feature of the two-dimensional code. And the experience of inhabiting a three-dimensional world is consciousness, experiencing its own projection, the boundary code, reading itself and interpreting the result as a world of depth, distance, and spatial extension. If consciousness belongs to the boundary rather than the projection, then several puzzling features of conscious experience would be explained. The unity of consciousness, the fact that your experience is a single, integrated whole, rather than a collection of separate sensory fragments, would be natural if consciousness is a property of the boundary code, which is unified and integrated by its mathematical structure. The non-spatial quality of consciousness, The fact that your experience does not feel like it occupies a specific location in space, despite being associated with a brain that does, would be natural if consciousness belongs to a level of reality where three-dimensional space does not yet exist. And the irreducibility of consciousness, the fact that subjective experience cannot be decomposed into simpler physical components, which is the core of the hard problem, would be natural if consciousness is not a property of the projected world at all, but a property of the code from which the world is projected. You cannot explain consciousness in terms of the projection, because consciousness is not part of the projection. It is the projector. The physicist Paavo Pilkkonen has argued that David Bohm's implicate order is best understood as the holographic boundary, the level of reality from which the explicate order of the physical world is projected. Consciousness, in Bohm's framework, is a feature of the implicate order, not the explicate order. It belongs to the deeper level, not the projected level. And the experience of being a conscious being in a three-dimensional world is the experience of the implicate order, reading its own projections, the code, interpreting its own output, the ground of reality experiencing the world it generates. The black hole, in this framework, is the place where the holographic nature of reality becomes visible. Normally, the projection is seamless. You cannot tell that you are living in a hologram, because the projection is so faithful that it is indistinguishable from a genuine three-dimensional reality. But at the event horizon of a black hole, the projection breaks down. The two-dimensional code and the three-dimensional projection come into conflict. The firewall paradox, the complementarity problem, the contradictory descriptions of the same event by different observers. The black hole is the place where the seams of the hologram show, the place where the projection fails to fully conceal the boundary from which it is generated, the place where you can, if you look carefully enough, catch a glimpse of the code behind the world. This is why we have called it the mirror horizon. The event horizon of a black hole does not show you a distant object in the sky. It shows you the structure of reality itself. It shows you that the world you inhabit is a projection. It shows you that the information you thought was inside things is actually on the surface of things. It shows you that the three-dimensional depth you experience is not fundamental, but emergent. And it shows you that the boundary between the observer and the observed, between consciousness and the world it perceives, may not be the boundary you think it is. The mirror does not reflect your face. It reflects the nature of your reality, and what it shows is that reality is not what it appears to be from the inside. It is something far stranger, far more unified, and far more intimately connected to consciousness than the three-dimensional projection suggests. In the final stage of this investigation, we will bring all of this together. The black hole physics, the holographic principle, the information paradox, the contemplative traditions, and the question that has been implicit throughout. If the universe is a holographic projection, and if consciousness belongs to the code rather than the projection, then who are you? Are you a three-dimensional being living in a three-dimensional world, or are you the boundary code itself, experiencing its own projection from the inside? And if the event horizon is a mirror, what is it that you see when you look into it? The Tibetan Buddhist master Tulku Urgyen Rinpoche was once asked to describe the nature of mind. He said, "It is like looking at a mirror. You do not see the mirror, you see the reflections. But the reflections are not the mirror. Turn your gaze around, look at what is looking, and you will find the mirror itself empty, luminous, and without boundary. This is the mirror horizon, the event horizon of a black hole, the boundary of the holographic projection, the surface on which the code of reality is written, and the nature of the consciousness that reads it. The answer, as we will discover, may be the oldest answer in human history, and the most modern one. We have now traced the black hole from its origins in Schwarzschild's mathematics through the event horizon's observer-dependent nature, through the information paradox and its holographic resolution, through the discovery that space-time is emergent and woven from entanglement, and through the convergence of these discoveries with the deepest claims of the contemplative traditions. Now we must bring all of it together and ask the question that this entire investigation has been building toward. If the universe is a holographic projection from a two-dimensional boundary, and if black holes are the places where the holographic nature of reality becomes visible, and if the event horizon is a mirror that reflects the structure of reality back to the observer, then what are you? Where are you? And what does the mirror show you when you look into it? Let us begin with the most unsettling implication of the holographic principle, the cosmological horizon problem. You have a horizon, not the event horizon of a black hole, which is far away and exotic. Your own personal horizon. The cosmic horizon, the boundary of the observable universe, is located approximately 46 billion light-years away in every direction. Beyond it, the universe presumably continues, but no information from beyond the horizon can reach you. No light, no signal, no gravitational wave, nothing. The cosmic horizon is, for you, the absolute edge of reality. Everything that exists for you, everything you can see, measure, know, or interact with, is inside your cosmic horizon. Everything beyond it is, in a rigorous physical sense, non-existent as far as your experience is concerned. Now here is the remarkable fact that we discussed in the previous stage. Your cosmic horizon has exactly the same mathematical properties as the event horizon of a black hole. It has an entropy proportional to its surface area. It produces thermal radiation through the Gibbons-Hawking effect. It defines a causally disconnected region from which no information can escape, and the holographic principle applies to it with full force. All the information contained within your observable universe, every galaxy, every star, every atom, every quantum state is encoded on the two-dimensional surface of your cosmic horizon. The physicist Raphael Bousso formalized this in his covariant entropy bound, showing that the maximum entropy, the maximum information content of any region of spacetime, is bounded by the area of the boundary of that region, measured in Planck units. Applied to the observable universe, the Bousso bound tells us that the total information content of everything we can observe is determined by the area of the cosmic horizon. The interior, the three-dimensional volume containing hundreds of billions of galaxies, is a projection from the surface. The surface is the code. The galaxies are the hologram. This calculation is staggering in its implications. The total number of bits encoded on the cosmic horizon is approximately 10 to the power of 122, the largest number with physical significance in cosmology. And every one of those bits contributes to the three-dimensional world you experience. Your reality, the room you sit in, the planet you stand on, the galaxy you orbit, the galaxy clusters visible through your telescopes. All of it is the readout of 10 to the 122 bits of information inscribed on a surface you will never reach. The cosmic horizon is the ultimate holographic screen, and you are living inside its projection. There is a further subtlety that deepens the analogy with black holes. The cosmic horizon is not static. The universe is expanding, and the expansion is accelerating due to the dark energy that pervades all of space. This means that the cosmic horizon is not a fixed surface at a fixed distance. It is a dynamic boundary that is constantly changing as the universe evolves. Galaxies that are currently inside your horizon will eventually cross it as the expansion carries them away faster than their light can travel back to you. They will disappear from your observable universe, one by one, as the acceleration of expansion pushes them beyond your reach. Information that was once accessible to you will become permanently inaccessible. Your holographic screen is shrinking, and the projection it generates is becoming progressively less detailed, less complex, less rich. In the far future, trillions of years from now, the observable universe will contain only the gravitationally bound structures that are close enough to resist the expansion, our local group of galaxies, and nothing more. Every other galaxy will have crossed the horizon. The cosmic microwave background will have redshifted to undetectable wavelengths. The evidence for the Big Bang will have disappeared. A civilization arising in that distant future would look out at the sky and see only their local galaxies, surrounded by empty darkness. They would have no way of knowing that the universe was once filled with hundreds of billions of galaxies. The holographic projection would be reduced to a dim shadow of its former richness. The information on the boundary would be thinning. The mirror would be going dark. But your cosmic horizon is not a fixed, universal boundary. It is personal. It depends on where you are in the universe. An observer in a galaxy a billion light years away has a different cosmic horizon. It is centered on them, not on you. Their observable universe overlaps with yours but is not identical to it. There are regions inside their horizon that are outside yours, and vice versa. Each observer has their own horizon, their own boundary, their own holographic screen. The universe does not have a single holographic boundary. It has as many boundaries as there are observers. This is a striking echo of the contemplative tradition's insistence that reality is fundamentally perspectival, that what you experience as the world is a function of your position, your perspective, your level of awareness. The Islamic concept of tajalli, the self-disclosure of the divine, is always described as relative to the receiver. God discloses different aspects of the divine reality to different consciousnesses, depending on their capacity to receive. No two souls see the same tajalli. No two mirrors reflect the same light in the same way. The holographic principle provides the physics for this. No two observers have the same boundary, and therefore no two observers are living in the same holographic projection. The implications of this for the nature of personal reality are extraordinary. If your observable universe is a holographic projection from your cosmic horizon, then your reality is, in a precise physical sense, your projection, not your psychological projection, in the Freudian sense. Your physical projection, the literal mathematical holographic rendering of information from your personal boundary surface. The galaxies you see in your telescopes, the ground beneath your feet, the air you breathe, the people around you, all of it is a holographic image generated by information encoded on your cosmic horizon. Your reality is your hologram. This personalization of the holographic projection raises a profound question about the relationship between consciousness and reality. If each observer has their own holographic boundary, and therefore their own holographic reality, then what is the relationship between your reality and mine? Are we living in the same universe? Or are we each living in our own holographic projections that overlap in certain regions and diverge in others? The physics suggests the latter. Your cosmic horizon and mine are slightly different. The information encoded on your boundary is slightly different from the information encoded on mine. The three-dimensional world you experience is not identical to the three-dimensional world I experience, not because we perceive the same world differently, but because we are literally living in different holographic projections from different boundary surfaces. The overlap between our projections, the region of space that is inside both our horizons, is the shared reality in which we can interact, communicate, and form relationships. But beyond the overlap, our realities diverge into regions that are uniquely our own. This sounds like solipsism, but it is not. The holographic principle does not say that your reality is subjective or imaginary. It says that your reality is real, but perspectival, that the universe you experience is a genuine projection from a genuine surface, but that the surface is centered on you, and therefore the projection is centered on you, and therefore your experience of reality is irreducibly your own. Other observers have their own projections, equally real, equally valid, but not identical to yours. Reality is not observer independent. It is not a single, pre-existing stage on which all observers act out their lives. It is a multiplicity of holographic projections, one for each observer, overlapping in the regions of shared experience and diverging in the regions of individual perspective. Now, combine this with what we established about consciousness. If consciousness is not a property of the three-dimensional projection, but a property of the two-dimensional boundary code, if awareness belongs to the informational ground from which the physical world is rendered, then you are not a three-dimensional being living inside a holographic projection. You are the boundary code itself, experiencing its own projection from the inside. You are the screen watching the movie it is generating. You are the code reading its own output. You are the two-dimensional information that is experiencing itself as three-dimensional space. This is the mirror horizon. The event horizon of a black hole shows you that reality is observer-dependent. The holographic principle shows you that reality is a projection, and the cosmic horizon shows you that the projection is personal, that your reality is your hologram, generated by your boundary, encoding your information. The black hole is a mirror, because when you look at it, what you see reflected back is the structure of your own reality, not the reality of the universe as it is in itself. The reality of the universe as it is for you, a holographic rendering from your personal boundary surface, experienced by the consciousness that is, at the deepest level, not inside the rendering, but identical to the code that generates it. Every contemplative tradition we have examined reaches this same conclusion through its own methods. In Islam, the Sufi doctrine of the perfect human, al-insan al-kamil, describes the realized human being as a mirror in which God sees himself. The perfect human does not merely worship God from a distance. The perfect human becomes the surface on which the divine reality is reflected in its completeness. Ibn Arabi writes that God created the cosmos to be known, but the cosmos alone cannot know God in return. Only the human consciousness, when fully purified and perfectly polished like a mirror, can reflect the divine light back to its source. The human being is, in Ibn Arabi's framework, the mirror that makes God's self-knowledge possible. Without the mirror, the light has nothing to reflect in. Without the human consciousness, the divine information has no surface on which to be read. This is structurally identical to the holographic relationship between the boundary code and the conscious observer. The code contains all the information, but information without an observer is not yet knowledge. It is potential, not actual. The observer is what transforms information into experience, what reads the code and renders it as a world. And the perfect human, in Ibn Arabi's framework, is the observer who reads the divine code completely, who renders the full hologram, who reflects the total light, who experiences the entire projection without distortion. Ibn Arabi develops this mirror metaphor with extraordinary technical precision. He identifies different levels of mirroring, different degrees of polish, different capacities for reflection that correspond to different levels of spiritual realization. A rusty mirror reflects a distorted image, a clean mirror reflects a clearer image, and a perfectly polished mirror reflects the divine light without any distortion at all. The spiritual path, in Ibn Arabi's framework, is the progressive polishing of the mirror of consciousness, the removal of the distortions, the biases, the ego constructions that prevent the mirror from reflecting the divine light accurately. Each veil that is removed, each distortion that is polished away, allows more of the divine information to be reflected, more of the boundary code to be read, more of the holographic projection to be experienced in its fullness. The Quran describes this polishing process with an image that connects directly to the holographic framework. God is the light of the heavens and the earth. The likeness of his light is as a niche within which is a lamp. The lamp is in a glass. The glass is as if it were a shining star. The glass is the mirror of consciousness. The lamp is the divine light. And the niche is the structured context, the boundary surface, the holographic screen within which the light is focused and reflected. The more transparent the glass, the more light passes through. The more polished the mirror of consciousness, the more of reality it reflects. In Christianity, the concept of the Imago Dei, the image of God in which humanity is created, acquires extraordinary depth in the holographic context. To be created in the image of God is to be a reflection of the divine reality, a holographic projection that contains, in encoded form, the information of the source. But an image is not merely a passive copy. An image is a rendering, a projection that makes visible what was previously invisible, that gives form to what was previously formless, that translates the infinite into the finite so that it can be known. The human being, created in the image of God, is the holographic projection through which the divine source becomes knowable to itself and to the creation. The image is not less than the source. The hologram is not less than the code. It is the code, rendered into a form that can be experienced. The theologian Meister Eckhart described the relationship between the soul and God in terms that directly anticipate the holographic framework. Eckhart wrote that there is a point in the soul, the ground of the soul or the spark, where the soul and God are not merely connected but identical. At this deepest point, there is no distinction between the human and the divine. The ground of the soul is the ground of God. The spark in you is the same fire that sustains the cosmos. In holographic terms, at the deepest level of the code, the information that constitutes your consciousness and the information that constitutes the divine reality are the same information, encoded on the same boundary, generating the same projection. In Hinduism, the Mahavakyas, the great sayings of the Upanishads, express this with unsurpassable directness. Tat tvam asi, thou art that. Aham brahmasmi, I am Brahman. Prajnanam Brahma, consciousness is Brahman. I am Atma Brahma. This self is Brahman. 4 statements, each from a different Veda, each asserting the same truth. The individual consciousness and the ground of reality are identical, not similar, not connected, identical. The code and the projection are not 2 things. They are one thing, experienced from 2 perspectives, from the inside as the world, from the deepest point of awareness as the boundless, formless, infinite ground. The Zen tradition cuts to the heart of the matter with characteristic economy. The koan. What was your original face before your parents were born? Is not a riddle. It is an invitation to look past the holographic projection, past the body, past the brain, past the 3-dimensional world that your consciousness normally inhabits, and to apprehend directly the boundary code from which the projection is generated. Your original face is not a face at all. It is not 3-dimensional. It is not spatial. It is not temporal. It is the informational ground from which face, body, world, and time are all projected. And to see it is to recognize that you were never inside the hologram. You were always the hologram, the code, the surface, the mirror from which the entire 3-dimensional world is reflected. Rumi captures the mirror horizon in verse after verse of his Masnavi, but perhaps most directly in this image. I have lived on the lip of insanity, wanting to know reasons. Knocking on a door, it opens. I have been knocking from the inside. The seeker who searches for the truth of reality is searching from inside the holographic projection. The door they are knocking on is the boundary between the projection and the code. And when the door opens, they discover that they were never outside the door. They were always on the side of the code, knocking on the inside of the projection, trying to get to a place they had never left. Awakening is not a journey from here to there. It is the recognition that here and there are the same place, that the code and the projection are the same information, experienced from two perspectives. In Buddhism more broadly, the concept of Buddha nature, the inherent capacity for awakening that exists in all sentient beings, is the direct assertion that every conscious being has access to the boundary code. Not every being perceives it. Not every being recognizes it. The three-dimensional projection is compelling, immersive, and very difficult to see through. But the code is always there, always accessible, always shining through the projection for those with eyes to see it. Awakening is not the acquisition of something new. It is the recognition of something that was always present, the boundary code, the ground of reality, the mirror behind the reflections that the Dzogchen tradition describes. In Islam, a hadith states, "He who knows himself knows his Lord." This is the holographic principle in 8 words. To know yourself, to perceive the deepest nature of your own consciousness, is to perceive the code from which reality is projected. And to perceive the code is to perceive the source of the code, the divine reality that is encoded on the boundary and projected as the world. Self-knowledge and knowledge of God are not two different kinds of knowledge. They are the same knowledge, accessed from two directions from inside the projection, looking inward toward the code, and from the code, looking outward toward the divine source that encodes it. The mirror works in both directions. Look inward and you find the code. Look through the code and you find God. Look at yourself and you find everything. So what does the mirror horizon show you? It shows you that you are not what you think you are. You think you are a three-dimensional being, made of matter, occupying space, moving through time. The holographic principle says that the three-dimensional space you occupy is a projection. The matter you are made of is an informational pattern, and the time you move through is an emergent feature of the entanglement structure on a boundary you will never see with your physical eyes. It shows you that the boundary between you and the world is not where you think it is. You think the boundary is at your skin, inside is you, outside is the world. The holographic principle says that this boundary is a feature of the projection, not of the code. In the code, the information that constitutes you and the information that constitutes the world around you are woven together on the same surface, entangled in the same pattern, aspects of the same holographic structure. The separation between self and world is a property of the rendering, not of the reality. It shows you that the black hole is not a distant, exotic object that has nothing to do with your daily life. The black hole is the place where the nature of reality becomes undeniable, where the holographic structure, normally invisible, becomes visible, where the observer dependence of reality, normally hidden, becomes obvious, where the mirror, normally transparent, becomes opaque enough to see your own reflection in it. The black hole is not out there. It is the deepest truth about the nature of right here, and it shows you something that the contemplative traditions have been saying for as long as human beings have turned their attention inward, that the observer and the observed are not separate, that consciousness and its objects are not two things but one thing, that the mirror and the reflections are not made of different stuff, that the boundary and the projection are aspects of a single, undivided, self-knowing reality. The physicist looking through the Event Horizon telescope sees a shadow surrounded by light, the dark silhouette of a region from which no information escapes, ringed by the incandescent glow of matter spiraling inward. It is the most dramatic image in the history of astronomy. But it is also, if you understand what you are looking at, the most intimate. Because the shadow is not just a feature of a distant object. It is a feature of reality itself, a demonstration that at the deepest level, the universe is structured as a boundary surrounding a mystery, a surface encoding an interior, a known surrounding an unknown. And that structure is the structure of consciousness itself. Consciousness is a known surrounding an unknown. It is an experience surrounding a mystery. It is a surface of awareness enclosing a depth that awareness cannot fully penetrate. The mystery of why there is awareness at all. The mystery of what awareness is. The mystery of the ground from which awareness arises and to which it returns. The black hole is a mirror. When you look into it, you see the structure of your own awareness reflected back to you. The event horizon is the boundary of what you can know. The singularity is the mystery at the center of what you are. And the holographic surface, encoding every detail of the interior in its two-dimensional pattern, is the code of consciousness itself, the informational ground from which your entire experience, your entire world, your entire reality is projected. Physics has given us the equations. The contemplative traditions have given us the maps, and the black hole has given us the mirror. What you see in it is up to you, but the traditions, across every civilization and every century, offer the same advice. Do not be afraid of the darkness at the center. The darkness is not empty. It is full of information, full of potential, full of everything that the holographic surface encodes and the three-dimensional projection renders. The singularity at the center of the black hole is not a point of destruction. It is a point of infinite density, a point where all the information of the universe is compressed into a single, undivided, infinitely concentrated seed. And the singularity at the center of your consciousness, the irreducible mystery of why you are aware, of what awareness is, of where the observer ends and the observed begins, may be the same point, not metaphorically, not poetically, but in the deep, structural, holographic sense that physics is beginning to articulate and that the contemplative traditions have always described. The Quran says, "Wherever you turn, there is the face of God." The Upanishads say, "All this is Brahman." The Heart Sutra says, "Form is emptiness, emptiness is form." The Gospel of John says, "All things were made through the Logos, and without the Logos was not anything made that was made." And the holographic principle says, "All things are projections from a two-dimensional boundary, and without that boundary, nothing that exists would exist." They are all saying the same thing. They are all describing the same structure. They are all pointing at the same mirror. The question is not whether the mirror exists. The physics has confirmed it. The event horizon is real. The holographic principle is real. The observer dependence of reality is real. The information theoretic structure of the universe is real. The question is whether you will look into the mirror and recognize what you see. Whether you will see a distant astrophysical object, interesting but irrelevant to your daily life. Or whether you will see, reflected in the dark surface of the event horizon, the deepest truth about the nature of your own consciousness, that you are not a being in the universe. You are the universe being. You are not a projection watching a screen. You are the screen, projecting a world. This is not a comfortable truth. It is not a truth that settles the mind and soothes the ego. It is a truth that dissolves the ego entirely, that reveals the separate self as a feature of the projection, not of the code, and that invites you to release your identification with the projection and recognize yourself as the code from which the projection arises. The traditions call this recognition by many names: enlightenment, moksha, fana, theosis, satori. The physics does not use these words, but it describes the same structural shift, the shift from identifying with the three-dimensional content of the holographic projection to recognizing oneself as the two-dimensional informational ground from which the content is generated. This shift is not destruction, it is expansion. You do not cease to exist when you recognize yourself as the code rather than the projection. You exist more fully. because you recognize that you are not limited to one location in the projection, one body, one perspective, one lifetime. You are the entire code, or rather, you are the awareness that reads the code, the consciousness that renders the projection, the observer for whom the holographic boundary generates a three-dimensional world. And that awareness has no edges. It has no boundary. It has no event horizon of its own, because it is not a thing within the projection. It is the condition for the projection's existence. You are not standing in front of the mirror. You are the mirror, reflecting everything that is. We must, as always, be honest about the limits of what we have established. The holographic principle, while supported by extensive theoretical evidence including the ADS-CFT correspondence, has not been experimentally confirmed in our universe, which has a positive cosmological constant rather than the negative one in Maldacena's model. The connection between consciousness and the holographic boundary is a philosophical interpretation, not a proven scientific fact. The contemplative traditions offer testimony, not laboratory data, and the structural parallels between physics and mysticism, however precise, do not constitute proof that they are describing the same phenomenon. But the convergence demands attention. When multiple independent lines of investigation, theoretical physics, information theory, consciousness studies, and contemplative practice all arrive at the same structural conclusion through entirely different methods, the probability that the convergence is coincidental decreases with each additional line. The holographic principle says reality is a projection from a boundary. The contemplative traditions say the material world is a manifestation of a deeper ground. The holographic principle says information is more fundamental than space. The traditions say consciousness is more fundamental than matter. The holographic principle says the boundary contains more reality than the projection. The traditions say the divine ground contains more reality than the created world. At some point, coincidence becomes an inadequate explanation, and the convergence itself becomes evidence, not proof, but evidence that these independent investigations are describing the same underlying structure of reality. The black hole is the universe's confession. It is the one place where reality stops pretending to be something it is not, where the holographic nature of existence is laid bare, where the observer dependence of reality is undeniable, where the boundary between known and unknown becomes visible. And what it confesses is what every mystic, every sage, every contemplative tradition in human history has been trying to tell us. The mirror and the reflection are one. The boundary and the interior are one. The observer and the observed are one. And you, the consciousness reading these words, the awareness experiencing this moment, the irreducible fact of your own existence, are the one in which all of these apparent dualities dissolve. The physicist, the mystic, the philosopher, and the contemplative all arrive at the same edge. They stand at the event horizon of understanding the boundary beyond which the known methods of their tradition cannot take them further. The physicist reaches the singularity where equations break down. The mystic reaches the divine ground where concepts dissolve. The philosopher reaches the hard problem where analysis halts, and the contemplative reaches the state of pure awareness, where all content vanishes and only the fact of awareness remains. They are all standing at the same boundary. They are all looking into the same mirror, and the mirror shows each of them the same thing, that the boundary they have reached is not the limit of reality. It is the limit of their method. Reality continues beyond the boundary, but to follow it, they must stop using their instruments and start being the thing they are trying to study. They must stop observing consciousness from the outside and start being consciousness from the inside. They must stop standing in front of the mirror and recognize that they are the mirror. Look into the mirror. What you see looking back is not the black hole. It is yourself. And yourself is everything.